Welcome to the video on trigonometric limits. In this video we're going to solve limits that involve trigonometric functions, and we're going to solve 3 examples. To begin with, we need to know what I call the fundamental trig limit, and this limit is this one. We proved this limit in this video on the squeeze theorem, and this limit is the limit as x approaches 0 of sine of x over x equals 1. We proved this using the squeeze theorem, a little bit of geometry, and then the squeeze theorem. And this is the fundamental trig limit because it allows us to solve all other limits that involve trig functions. So let's begin. This is proved using the squeeze theorem. So let's begin with solving with some examples. Here we have a very similar limit to the fundamental limit. Here we have the limit as x approaches 0 of sine of 4x over x. In this case, here the trick is to multiply and divide by 4, because if we do that, we multiply by 4 here in the numerator, and here below also multiply by 4. And this 4 here in the numerator we can take out of the limit sign like this. And now we have sine of 4x over 4x inside the limit sign. And when x approaches 0, 4x also approaches 0. So here we have the fundamental trig limit with variable 4x. So this limit is 1 because it is the fundamental trig limit. So this equals 4 times 1, that's 4, and that's the answer. Let's see another example. Here we have the limit as x approaches 0 of tangent of x over x. And here solving trig limit is like solving trig identities. Here you need to use all the identities you know from trigonometry. For example, we can replace tangent of x by sine of x over cosine of x. If we do that, we can write this as sine of x over x times 1 over cosine of x. And here we have a product of two functions, and the limit of the product is the product of the function of the limits. And here we have the fundamental trig limit, so it approaches 1. And cosine of x approaches 1 when x approaches 0, so this also approaches 1. So this equals 1, and that's the answer. Let's see another example. This is more interesting. Here we have the limit as x approaches 0 of 1 minus cosine of x over x. Now we need to use a more elaborate trig identity, and we're going to begin with this identity that says that the sine of x over 2 equals this expression here. And note that we have in the limit we have 1 minus cosine of x, and that's exactly what appears here inside the square root over 2, right? So what we can do is to, in this equation, solve for 1 minus cosine of x. If we do that, we square both sides and we multiply by 2, and we get this equation. We just solve for 1 minus cosine of x, and we get that it equals 2 sine squared of x over 2. Now we can replace that expression in our limit. Here we have 1 minus cosine of x, and we can replace that by this 2 sine squared of x over 2. And now we're going to do a little trick. We're going to separate the sine squared as the product of sine times sine, like this. We're going to put the x below one of those, sine of x over 2. And now we're going to do a trick, the same trick that we did in the first example. We're going to divide by 2 in the first factor here. but when we divide by 2, we must also multiply by 2. And now we can take these 2 out of the limit sign, and it cancels with the 2 that we have here. So now we have this product, and here again we have the fundamental trig limit, but here the variable is x over 2 that also approaches 0. So this will approach 1, and sine of x over 2 approaches 0 because sine of 0 is 0. So this approaches 0. So this becomes 1 times 0, that's 0. And that's the answer. So you see that solving trig limits involves using some trig identities that you already know, and then trying to make use of the fundamental trig limit. So that's all for now. Thank you for watching, and see you next time.